We're privileged to have a new staff member at Homershams, and she raised a question yesterday that was very salient, and I thought, you know what, I should talk to my LinkedIn audience about it in case there's any misunderstanding about it. Absolute pressure is a concept that can be quite hard to understand, and if you know about it, you might want to skip this video. My customer yesterday had wanted a pressure transmitter that went from -1 bar to +1 bar. So that is, it went to a vacuum and it went to a positive pressure as well. Or to put it in American terms, to go from -14.7 psi to +14.7 psi. And talking to our staff member, we talked about the fact that an absolute gauge could be used to measure compound pressure. So if we look at Dwyer Omega, which is one of our big brands, of course, and we look at the range of gauges, at least pressure transmitters they have available, we see that there are a range of pressure models available, and this range, the lower range from 0 psi to 14 psi up to 300 psi, have an A at the end, which means absolute. What does that mean? Well, on Earth we live under a sea of air. I think we all know that when we dive underwater, we have pressure on us, and for example, at the bottom of the Marianas Trench, there is 1,000 bar of water pressure pressing on us, and of course it's not survivable and would crush things instantly. If you're a fan of the old submarine movies, you might remember warnings being given about approaching crush depth, etc. Apparently, and this may be anecdotal, in World War II they would hang a washing line between walls of the submarine, and as depth became greater and pressure became greater, the washing line would sag as an indication. Of course, now it's all double holed, etc., so it's not the same. Anyway, I'm drifting off the point. So we all know that under the sea, now I want to sing from The Little Mermaid, we have the weight of water pressing on us. Well, in exactly the same way, on the earth, just on the land, we have a great weight of air pressing down on us. You may have seen examples on the internet where 44-gallon drums or 200-litre drums are crushed. I should find an example and show you. By heating the drum such that the pressure is reduced within it, they then cool the drum and it instantly crushes. Let me call up a video while it's taking a long time. Okay, I'll put a link at the end. No, here we go. Let's have a look. Crushing 44-gallon drum. Okay, well there's an example as good as any. So this is a school experiment where what they're doing is heating the barrel, which has water in it. The water comes off as steam. We have greatly reduced pressure inside the drum. A lid is placed on, and then they cool the drum by squirting it with water or tipping ice on it. I'm not sure in this video what they do, but the lid goes on. So now we have a low pressure inside and we have a high pressure of the air outside. I'm guessing they're going to lift that into a pool of water. Yes, they are. And what happens is, as it cools, the pressure internally gets even lower, and given a little bit of time, air pressure will crush the can, and that just demonstrates that there is always pressure on us. Now, stalls for time, any minute now. I'll skip ahead a wee bit. Skip ahead. There we go. So you see that that large drum has been crushed purely by the air pressure that's all around us. So sometimes, most of the time, we want to measure pressure as we would see it in the room. So if I take an ordinary pressure gauge and I hold it in the room here, it would read 0 because it's reading pressure relative to normal pressure that we're under. But there are times when we need absolute pressure. So for example, if we look at a scale and we say let's say we have 0 pressure gauge, which is what we call it. So when we're measuring against local room pressure, we say that we have 0 pressure, 0 gauge pressure. And then as we, there we go, that's better. As we increase the pressure, obviously it goes up and up and up and up and up, and you might go to whatever. Let's say we go up to 1 bar. So if we use the example of the customer who wanted a 1 bar gauge or 14.7 psi. Now this customer wanted to go from negative pressure to positive, negative 1 bar to positive 1 bar. So now what we do is we use an absolute gauge to measure that. So if we look back at our Dwyer Omega data sheet, we see that the lowest range goes from 0 psi absolute to 15 psi absolute. That is compared to deep space, or the volume of my first wife's heart, whatever unit of measure you want to use. So if we have, so 0 gauge is not really 0. As I've said, we have 1 bar of pressure pressing on us, 1000 millibar, 14.7 psi. If you look at a weather forecast, if anyone still does that, not that one, that one, you often see isobars. Make that bigger so you can see it, where you can see lines of pressure, and this is showing the pressure around the area that you're in. So we can see on this particular day we had a reasonable high, which normally is a harbinger of good weather, and low pressure up here. And low pressure brings in more air because the high pressure air out is pushed into where there is no air. So if we go back to my rough diagram, so 0 gauge is actually one bar absolute, or 14.7 psi absolute. So you'll sometimes see that we say gauge, we could go 0 bar G for gauge. So if you see the term BARG, it means pressure relative. If we look at deep space, we have really got a vacuum. No pressure at all to speak of. Yes, there's a few molecules, but effectively it's 0. So it's 0 bar A, absolute. Which you can probably work out is the same as negative 14.7 psi or negative 1 bar. So a perfect vacuum minus 14.7 psi minus 1 bar, etc. So my customer who needs a minus 1 bar to plus 1 bar gauge simply needs to buy a absolute gauge like the model 626, 0 psi absolute to 15 psi absolute, and the output will be 4 to 20 milliamps, ranged across negative 1 bar to plus 1 bar. Just to give you a live example, here is an Additel very nice gauge that we use in our lab that measures absolute pressure, not gauge pressure. Obviously, a gauge that you'd be used to seeing would be showing 0, but of course we can see at the moment the room pressure, the pressure we're under from the weight of gravity, is 1008 millibar as near as damn it. And if we change units of measure, we can see that that is 1 bar absolute, 100 kPa, etc., and all the units of measure. So keep in mind, if you want to measure absolute pressure, it can be done with an absolute pressure gauge. Now, of course, the only mild caveat would be those who know about this stuff might say, yes, but if the pressure in your room varies, so it's a particularly nice day coming, you might have a very small millibar difference, but it's normally too small to be concerned about.